In this video, I'm going to go over our solution to our last practice problem for the Chapter 3 lecture, and this one has to do with dilution. So the problem is telling me that I have a 2.45 molar aqueous solution of ammonium that has a volume of 50 milliliters. So that's what I'm starting with. I'm actually, before I read anything else, just going to write that down. So my C1 is equal to 2.45 molar, and my V1 is equal to 50 milliliters. All right, let's keep going. So looking at that now, I see for part A, an additional 200 milliliters is added. What is the new concentration of the solution? So an additional 200 milliliters. And that additional is key. It means it's not my total volume, but I'm adding it to it. So that means that my volume 2 is going to be equal to that initial amount I have, the 50 milliliters, plus the additional 200, which will equal 250 milliliters, right? And now I need to figure out what the new concentration is. So I'm going to pull up my C1V1 equals C2V2 equation, and I'm going to plug in the values that I have into it and figure out what that volume or that concentration is. So I have 2.45 molar for my first concentration, and I have a volume of 50 milliliters. So now I can put in 50 milliliters since my second volume is also in milliliters, or I can convert both to liters. Either way, I'm going to keep it in milliliters. And that's going to be equal to my new concentration, which will be in units of molarity still, or moles per liter, because my first concentration is in those units, times my 250 milliliters. So that C2 is going to be equal to my 2.45 molar times my 50 milliliters divided by my 250 milliliters. Or my concentration is going to be 0.5 molar. Okay, so that's A. Let's look at B. So for B, it says what volume of the 2.45 molar solution would be needed to dilute it to a 0.15 molar solution that has a volume of 650 milliliters. So that 0.15 molar of my 0.15 molar 650 milliliter solution, this is my C2 and my V2 for problem B. So what I'm being asked here then is how much of that first amount. So my concentration is still 2.45 molar for my initial, but this time I'm going to take out an amount of it and not all of it. I'm not going to use all 50 milliliters. And so I don't know what that volume is. And that's what I need to learn. My concentration that I'm aiming for is 0.15 molar. And my total volume that I'm going to need is 650 milliliters. And again, look at the context of the language around this. It's telling you that you're going to form a solution that's 650 milliliters. So that total volume is 650. So let's set this up. So C1V1 equals C2V2. In this case, I've got my 2.45 molar for my C1, and it's going to be multiplied by some unknown volume that I'm going to try to calculate. And it's equal to my new concentration, which is my 0.15 molar. And that's going to be multiplied by that total volume that I want in the end, which is my 650 milliliters. So if I leave this in milliliters, right, this means that I'm going to get my answer. My V1 will have units of milliliters as well. Again, I can convert this into liters, and then I'll get out an answer in liters. So that volume 1 is going to be equal to 0.15 molar times my 650 milliliters divided by my 2.45 molar. So the volume that I need to take out and combine with water until I hit 650 milliliters is going to be 39.7959 milliliters, which is way too many digits. What should it be? Let's go back and look. I've got 3 significant figures for my first concentration. I've got 2 for my second concentration, and I have 2 significant figures for my volume. Everything I'm doing is multiplication or division, so I need to report this to 2 significant figures. Now that 7 rounds up the 9 though, so I'm going to end up with 40 dot milliliters. I have to show it's two significant figures, right? I have to show that 0 isn't a placeholder. So if I put a decimal after it, it shows that it's a significant figure. But I could also write this as 4.0 times 10 to the 1 milliliters and use scientific notation to show my sig figs. And that's how we would solve this one.